backyard. Berkeley is right up the street. Why didn't she find people who could talk about that issue there? And it's kind of an interesting puzzle. And again, maybe because there's so much focus on technology. So I want to thank Tamer for sponsoring my presentation. I'm part of the Tamer mafia, I guess, at this event as an advisory board member. And my talk is related to it, but I think much more contextual. It's about what we're doing with analytics these days and how and big data, and how it's all not going to work unless we do something better on the kind of data integration and curation front. So a little bit of context. I have been working on this subject for a while. This is me as a young scientist studying information management. No, just kidding. But in the 90s, I wasn't doing much yet on analytics, but I was really interested in information management, and I was highly distrustful, highly skeptical of how many organizations were dealing with information management then. I'll say more about it in a little while, but it's a very top-down approach, very engineering-driven approach, and partially because I guess I was a taxpayer, I was looking at some efforts going on in the Defense Department that appeared to be totally ineffective and incredibly expensive. Then I did other things, ERP, knowledge management, etc. Around the early 2000s, I started to say, you know, analytics might be an interesting thing to look at, as Matt suggested, and I wrote about that for a while, studied what companies were doing with it. 2012, I did a research project sponsored by SAS, who sponsored a lot of my research. In fact, they and Intel sponsored competing on analytics. I did this study with DJ Patil, who lives out here, co-coined the term data scientist when he was at LinkedIn, and the focus was on, you know, what do data scientists actually do? We interviewed about 25 of them. I have to give some credit to my editors at Harvard Business Review, who subtitled this piece, "The Sexiest Job of the 21st Century." I will actually, and by the way, don't get too much of a swelled head. It's sexiest job, not sexiest people, if you are one of those. But I'll have more to say about that in a second. It turns out my research suggested that job wasn't quite as sexy as that title might suggest, for some reasons related to my talk this morning. Then in 2013, I did another study with Jill Bechet from SAS, who is here at this event, on big data and big companies, and that and some other work resulted in a book called Big Data at Work. Not certainly the first book on big data, but I think the first book on how large established organizations were starting to use big data and get value from it, and how they organized it and so on. And then early this year, I did a study sponsored by Teradata, actually, on the rise of data discovery, sort of in a way, a response to the fact that data warehouses have been so successful that now we need a new environment for exploring data. So all of that is background to make you be persuaded, I hope, that I have looked at this subject for a while, and I think it's time for some new perspectives in the area. So a little bit of a history lesson. Analytics 1.0 started in 1954 or so, the first corporate analytics group I ever found. Very sort of reporting oriented. That's the dirty little secret of analytics. The vast majority of it through history has been descriptive analytics or reporting oriented. It was the definition of small data, small, structured, typically from internal sources. The analyst worked in the back rooms, largely invisible to decision makers. The focus, though, was on supporting internal decisions. It was all, you know, very internally focused, and I never liked that term decision support. It always sounded a little meepy, but many people refer to the whole concept in that way. Everything was very slowly developed. You know, we developed these models over months sometimes, and worked off a data warehouse. This was the era of the data warehouse, and as I said, it was pretty successful, so much so that we need a new model now. Analytics 1.0 data management, you may think this is the circuit diagram for the latest Intel or ARM processor, but no, it's a data model that organizations developed. People tended to call this information engineering or information architecture. The son of this movement in the 2000s was called master data management. A number of organizations are still wrestling with that. I call these top-down approaches. The idea is, we're going to model how information is going to be used throughout the organization. Only 3 problems with this approach. One, business people typically can't engage with it all. You can sort of look at this model and get the idea. This is not an entire company's model. This is one page of probably 50 or 100 that describe how information is supposedly going to be at some point in an organization. I would talk to business people and they said, I don't see my job in here. I don't see the information that I use in these models at all. So that was one problem. As I suggested about the DoD, billions of dollars spent on this with very little to show for it over the years. And master data management isn't finished, but I think it's fair to say we have a paucity of great examples of, well, I did master data management and made me an incredibly successful company. Thirdly, just doesn't work. So that's kind of 3 strikes, and one would think that we would sort of get rid of these approaches on that basis or set of factors, but it's not clear that we have yet. I guess hope springs eternal. Analytics 2.0 developed out here around the 2000s or so. The term big data didn't really take off until about 2010, but it involved using complex and large and unstructured data environments about customers and other things. In order to handle all that data, we needed some new computational approaches, i.e. Hadoop. To some degree, some analytical approaches, although mostly that didn't change as much as the computational approaches did. We had the emergence of data scientists, these people who could do both analytics and computational feats. We had a new set of objectives. So there was, when I talked to these data scientists, they would generally say things like, wow, decision support, creating PowerPoints and reports for decision makers, what a dead zone that is. DJ Patil, my co-author, kept saying, Tom, we need to persuade people, data scientists need to be on the bridge, man. And I was a little confused about this at one point. I said, DJ, what do you mean by this sort of on the bridge thing? And he said, on the bridge, right up there with Captain Kirk. And so I got it, okay, he's a Trekkie. I tried to join in. I said, oh, yeah, you mean like Dr. Spock? No, not like a deceased baby doctor. It's Mr. Spock, you fool, he might have said, but he didn't. I think I lost the respect of my co-author then, but the idea was right up there developing products and services for customers, not supporting backroom decision making. So a very different set of objectives for Analytics 2.0. You can see some of these examples. Google, basically everything is a data and analytics based product, including self-driving cars, described as just another big data exercise at Google. LinkedIn, Simon Zhang, my friend from there, is going to talk later on. They've done a fantastic job of developing data products that are extremely successful, bring more users into the site and retain them over time. Netflix has done very well in this regard. Zillow up in Seattle. Facebook, maybe a little less successful than some of these other companies, but I think now they've gotten religion about that as well. So you can see that this idea of data products is the primary objective. There's some smart organizations. Simon at LinkedIn now spends a lot of his time focused on internal decisions. So that didn't go away, and it's smart to do that as well. But the primary focus, at least initially, was on stuff for customers. Now, we come to this question of the sexiest job of the 21st century. And as I interviewed data scientists, I said to myself, wow, people spend a huge amount of time what they call munging data or extracting, filtering, cleaning data from various kinds of systems. I remember interviewing a guy at GE. He told me it took him 6 months to suck the data out of a locomotive alternator. Wow, what an exciting way to spend your time. And I kept thinking, these are not data scientists, they should be called data plumbers. And I decided that the emblem, the visual emblem, should be the plumber's crack. Now that's a pretty disgusting subject to look at, but I found this great image on Google Image that I hope will be more appealing. Babies' cracks are much more appealing than adult males. And this one is using a computer, so it was perfect in that sense. But the idea is that way too much plumbing is involved. Mark Schreiber is going to be, from Novartis, is going to be in a panel with me. He refers to it as not plumbing, but janitorial work. But you get the idea. Not sexy at all, because so much time needs to be spent doing this work. Mark says 90%. Some other people have said similar kinds of figures. Not analyzing data, but janitorial or plumbing work on data. The more sources and types of data you have, the more the plumbing work. And I've always felt that the big issue about big data was not the size, but actually the volume, the variety and lack of structure of it. And the more variety and lack of structure, the higher percentage spent on plumbing. Data scientists have not adopted these top-down approaches. I think they're probably smart in doing that. I don't know if they didn't have the patience or they somehow intuited that this wasn't an effective approach, but as a result, there hasn't been any concerted activity around data management for a lot of these people. We need to get much more productive about this if we're going to be successful. And the problem is likely to get worse before it gets better. I'm doing a research project now with a guy at MIT named Sanjay Sharma, who was very involved in the whole RFID movement. And now he's doing some work on automobiles. He has what he calls the Field Intelligence Lab. And he said, there are, in the average car today, over 350 sensors generating 250 different data formats. So if we're going to make any sense at all of the Internet of Things, we're going to spend a huge amount of time on the interconnection and data management of things unless we get a lot more productive at all of this. So Analytics 3.0, I think we're moving into a new age where we're combining small data and big data. Some of these 1.0 approaches and some of the 2.0 approaches. What organizations do, as I said about LinkedIn, in this case, is they say, great, I can create data products, or I can create better internal decisions. Both of those are important, so let's do both things. It's no longer just the LinkedIns and the Googles and the Facebooks of the world who do this kind of work. Now it's the GEs and the Monsantos and the JP Morgan Chases saying, we need to create data products as well. And all of those organizations have made substantial strides. You may have heard about GE's $2 billion investment in the East Bay, Monsanto paying $1 billion for Climate Corporation in order to be able to do predictive planting. JP Morgan Chase has a new intelligent solutions business. Barclays has a new business they call the information business, all designed to kind of do not just internal decision making, but data products. So we're combining traditional analytics and big data in a seamless way. Analytics becomes integral to everything that we do, not a back office thing at all, but something we push out to the front lines. In many cases, it's got to be rapid, agile, insight and model delivery. One of the people I interviewed, a CEO of a big data firm in Boston, said, you know, we tried agile, but that was too slow. We needed much faster delivery of products than that would allow. Pushing things out to the front lines, making analytical decisions available on mobile devices, all of these things are a function of analytics being everybody's job in the organization. So, you know, the subtitle, Fast Pervasive Impact in the era of Smart Machines. It sounds fantastic, doesn't it? But it's not going to happen unless we get a lot better at data integration. Unless we solve this bottleneck problem that is making our data scientists plumbers rather than scientists in many cases. So I think we are at the point where a lot of organizations would like to do this. We just have to get a lot better at the underlying activity. So Jill Deshay and I worked together on this slide about what kinds of data. You know, 1.0 tends to be the stuff on the left, the highly structured customer orders and bills of material and shipping notices and so on. 2.0, we start to get into more unstructured data around customer sentiment and recommendations and so on. 3.0 is everything, basically. All of this combined and even more, much of it external. The internal data really matters. Small data, big data. We ought to be calling it all data, I think, rather than big data. You notice nobody ever introduces themselves and says, you know, hi, I'm Joe. I work with small data. It's not an appealing title, but still that data can be very useful. So how do we combine all of this data from sensors and blogs and social feeds and clickstream logs and customer satisfaction and so on? Again, we've got to get a lot better at how we do this kind of work. So I think data management in this space, and I have been admittedly influenced by the approach that Tamer is taking. I think you'll hear more about it today at sort of their coming out party, but curation involving a whole variety of different approaches. Tamer uses a combination of machine learning and crowdsourcing, which I think is a good combination. There will probably be other ones that come along. Great, you know, we're going to need multiple approaches to make this work. Not from a top-down perspective, but sort of bottom-up, application by application. That seems to be the only thing that people really have an appetite for. But you hope that over time we capture some of that knowledge and have some enterprise-level aggregation of what we've done. Ideally, eventually embedded in a smooth workflow, so we know, okay, machine learning couldn't handle this problem, let's move to crowdsourcing or whatever other approaches we're going to use. Largely done by data science professionals and data professionals, but with some amateur involvement as well, the people who do the work of the organization. And we have to at some point incorporate some capabilities for data discovery too. I'll conclude with sort of a basic recipe for doing 3.0 work. You can't start with 3.0. You have to have an underlying basic data management capability. Add some unstructured large volume data to the mix. Think about products and services, not just internal decisions. A dash of Hadoop, a pinch of NoSQL. Some new technologies, cook it up in a high heat convection oven, that's where the sort of speed comes from, and then don't think that you can do all of this without adopting some new approaches to data integration and curation. It's just not going to happen without that. Thank you very much.